Welcome to erctipsknowlogy. In this video, we will see how to use Tinkercad in creating an Arduino simulation project that uses 8 LEDs that can be controlled by 2 switches to do the following. If switch 1 and switch 2 are both off, all the LEDs will also be off. But when switch 1 is the only one on and switch 2 is off, only the red LEDs will blink or toggle every 1 second. And thirdly, when switch 2 is on and switch 1 is off, the other LEDs except red will blink. Now to do that, we need a simulator, and the simulator I'll be using here is the Tinkercad Simulator. So what I'll do is, of course, we need the Arduino Uno. Let's put it over here. And we need a breadboard. You can also click this part to fit the breadboard and the Arduino in our screen or on our screen like that. But if you prefer a bigger one, you can use the scroll button on your mouse, the scroll part, mouse, and you can make it bigger. You may also press Ctrl minus and Ctrl plus on the keyboard to adjust the size of your parts. Now we need 8 LEDs, so I'll put one LED here on this part, number 27, number 28, and then we'll put one resistor that will be connecting the resistor to the negative, for example, and let's make it 220 ohms to make our LED brighter. And then the other leg of the LED, which is the anode, will be connected to, let's say, digital pin number 0 of your Arduino. And let's change the color of this to red. So that's it. You have your first LED. And then we can copy this LED, Control C, Control V, and you can put it here. Control V on the keyboard to do the third, and so on. So let's create 8 LEDs for our simulation project. And let's make this one yellow, and that the fourth we will make it green. This will be yellow, and Control V, let's put another one here which will make us green. So just click the LED and choose the color over here. That's it. And we can replicate or duplicate this resistor, which we connect on the anode side of each of the LEDs. So I'm just using Control V, but before that I click Control C. Okay, and then we will assign each of the LEDs on our digital pins. Like the second red colored LED, we'll put it on D1, and then the yellow we'll put on D2, green on D3, the red on D4, the other red here on D5, another yellow on D6, a green on D7, and we may change the color of these wires to represent them better, so that it will not be difficult to look at them. So this one will be green, and it's easier to troubleshoot in case you have some mistakes in your circuit. Okay, so you may change the appearance and make it more presentable. Depends on you how you will manage this one, but in my case, I'm clicking the wires here and pulling it down. Just make sure that you are connecting the LEDs on its proper pins. So let's say this one, you can still bend it here. Depends on how you look at it. If you feel it's not presentable, you may still make it presentable by arranging the wires in such a way that it's not bad on the eyes of the one looking at your project online. Okay, so now I have shown you the bending of the wires. So just click them and double click if you want to put another connections here that you can adjust. Of course, it will take time sometimes to do this, but this is for presentability of your project. You cannot just put spaghetti-like wires over here. So It's better to arrange them before you continue. Now I have the red, red, yellow, green, red, red, yellow, green wires connected to digital 0, digital 1, digital 2, or we can just call it D. D3, D4, D5, D6, and D7. Of course, the cathodes of the diodes, you can find it by just moving the pointer over the leg of the diode. Like here, it's cathode, cathode, cathode. All right, so this is the cathode side or the cathode terminals of our LEDs, which are in series with our resistor, and the resistors share a common line, which is the negative side of the breadboard. Now what I'll do is I'll connect the negative line or negative connections here to the ground. Okay, so in other words, all of these LEDs are now connected to the ground of the Arduino Uno. Now let's say that let's check if the connections are fine. You just click code and go to the blocks, click the text, and of course you will be seeing it a default program, which is given already here in the IDE of our editor. So from here, you can see that the pin mode LED built-in is there, and we need to change this to a number which represents the digital pins that we use, and that will be digital pin 0, and we will say that this is serving as an output, and we will also copy this and make it replicated into 8 LEDs. So what I'm doing now is I'm just copy pasting the commands or the pin mode 0 output for the meantime, and then I will be changing it to its correct digital pin names. So from here, I'll make it 1, and then 2, 3, 4, 5, 6, and 7. You can click code to remove this code, and as you can see, the anode of our LED is connected to T0, and the last LED is connected to T7, which is colored as green. So let's go back to the code. So this part is like declaring that our pins 0 to 7 will serve as an output or output pins. Now in the void loop part or function, we will try to turn on all of them. So we can put here a variable, for example, variable x, and high. To turn it on, we can replace it with 1. Now instead of writing all of the numbers, we can also use a for loop for x equals 0, x less than 8, for example, and then we will put here x plus plus. And this will turn on all of the LEDs because this will become 0, 1, 2, 3 up to 7, and because it's 1, it will be turned on. We will not use any delay for the meantime, and just to check if this will be okay. So let's run the simulation. So there's an error because x was not declared in our program. So we will declare the variable x here. So we may put it before the for loop. So we will put here, for example, int x to make it like an integer variable x start. That's it. And as you can see, all of the LEDs turned on. Now what we do is we need a switch. So we will ask if a switch, for example, which we will put on our breadboard, we need to put a switch here. Okay, so what I'll do is I'll look for a switch. This one is light switch, maybe we can use that and put it over here. Okay, and of course that switch must be connected to one of the digital pins here also. So I'll put this yellow wire a little higher, also this red wire, to make a room for the connector for our switch. Okay, and then the middle part of the pin, which is common, we will click it, and I will be connecting it to our digital pin number 8. Okay, so let's say that the other part of the wire is connected to the digital pin number 8, and we can check if it is actually high or low later on by by our program, with our program. And we can also put a resistor. Let's say, let's copy this resistor, Control C, Control V, and let's connect that resistor to the other side here. And that one will be connected to the ground. Or we can connect it to the positive side of the breadboard. Now this breadboard positive, we will connect it uh, to the ground. Not to the ground, I mean the 3 volts, 3 volts or the 5 volts. So our Arduino Uno has 3 volts or 5 volts here, 3.3. So let's try 3.3. And this 3.3 we will be connecting to the positive of the breadboard. Let's make it red. That's it. Okay. Now the 3.3 volts is connected to the resistor, and the resistor is connected to terminal 1 of our slide switch, and the common is connected to number 8. Now if I go to the code, we have to declare, let's say, pin mode here, but as an input because we are using a switch. So I'll put here pin mode number 8, but I'll make it input. So this will be input. Okay. Now we can check if that switch is equal to 0 or equal to 1, if it is high or low, by reading this switch. So we can say digital read, open bracket, and let's put the number of our switch, number 8, or yeah, digital read 8 equals 1. We will turn on all of the LEDs. But if it is not 1, so we can just put here else, we can turn off all of the LEDs. So how to do that? We can copy this part and let's just put it on the else of the if statement. So here we will do the same, but instead of 1, I'll be putting 0. So this part is turning on the LEDs, and this one will be turning off all the LEDs. Let's try it. So let's start the simulation and hide the code. Let's see. So there's an error because of the bracket. So let's see what line number 22. So I'll go there. So this is the error, line number 22. But I have the open bracket here and the close bracket there. So the other side of the if 19 has no partner, so we have to put a close bracket over here before that else statement. So let's click the start code. There you go. So all of the LEDs are currently on, but let's try to turn off the switch. Okay, let's stop the simulation. It did not turn off. So again, turn off, turn on. It's not happening. So let's check the code. Let's go to the code. If digital read 8 equals 1, this will be the result. Else, this will be output. So what will we do now is we have to check the output here. Let's try if it is 0. Okay, and we will reverse this one. Control X, I'll put it here. And the other one, which is off, Control X, I'll put it over here. All right, now what we do is, what we have done is we just replaced the off switch here. Make sure it's really off. And let's try it again. Start simulation code. See? So if I click this, still. All right, so let's connect this to the ground. See? Turn on. Yeah, that's it. So the problem is that the other side of the switch was not connected to the ground. So when you connect this to the ground, then it will be zero. But when you connect it to when you click this switch, okay, and it's now connected along this resistor, then it will be a high or it will not be zero. So let's try to go back to our code again. Let's make this one, or let's press Control Z or Control Z or Control Z. Make it go back to the original program, yes. And then let's run it. Okay, so all LEDs are on, but when I click this switch, then it will be off. That's it. So now we can say that the 8 LEDs can be controlled by this switch, which is when it's on, all the LEDs will be on, and when it's off, all the LEDs will be off. Now let's fix the wiring because it does not look good. So I will double click this, stop the simulation, double click this wire, and then we will try to find a way to make this look better. I think this is better. All right, and then this is the other one here, or we now in the problem we are supposed to make not just one switch, but we need to make two switches. So I will just copy the switch that we have, or we can click the slide switch here, and we can, right? And I'll do the same. I'll use another resistor to be placed on the terminal here, and we will also connect the common terminal to a particular pin, which can be number 9. Now, just to have a difference, I'll choose blue for my second switch. The first switch I'll use purple. And then the other terminal 2 will be just directly connected to the ground. That's it. Like this one. This is supposed to be ground, so black. Now I have switch number 2 on digital pin number 9. So I have to change my code. I have to make it with pin mode 9. Mode 9 as an input, just to make it formal. But sometimes you don't even need to declare the switch as an input. We'll try it later on because it's still working even without putting this pin mode 8 and 9, just for the, I think. So now we can have another condition here that if switch 1 and switch 2 are both off, so and switch 2, so we can read digital read 9. If we want it to be checked as off, then we will need to put 0 here, and also here we need to put 0 also. So this means that the switch number 1 equals 0 and switch number 2 is also 0, but this is supposed to be 9, not 8. Okay, so when switch 1 and switch 2 are both off, all the LEDs are also off. So we will make all of the LEDs off. We make this 0. So that's the condition. All right. Now, when switch 1 is on and switch 2 is off, then we can copy this. What will we do if the switch 1 is on and switch 2 is off? Let's try to have a separate if. We'll just put them together later on. So if digital read 8, that switch 1 is on, so we make this 1, and digital read 9, which is switch 2, is off, so that's 0. Take note of the and the logical operator here. I use 2 ampersand symbols. Okay, and what will we do is only the red LEDs will blink. So in this case, what will happen is we need to identify the position of the red LEDs. So where are the red LEDs? It's on digital 0, 1, 4, and 5. So 0, 1, 4, 5. So what I'll do is I really need to put 1, digital right 1. Only the red LEDs will blink. So 1, what else? We have to do the 4 red LEDs. So these are on 0, 1, 4, 5. 0, 1, 4, 5. So I'll put here digital right 0, 1, 4, then 5. That will be making them off. And after that, we will make them on. So we will put a delay here, like we can say delay, and directly is delay 1 second. So 1000 millisecond. And then we will cancel this part. We will make it turn on so that it will blink. That's it. And so the 4 red LEDs will be off, and after 1 second it will be on. So we have to put here 1, 1, 1. How about the remaining LEDs? Now, by the way, if we can just turn off all the LEDs instead of simply turning, if we can simply turn off all of the LEDs, then we can use the for loop to do that. Anyway, in the 8 LEDs that we turn off, all the reds will be included. So I might as well use this one, which is to make it like turn off all of the 8 LEDs. And then we have the delay of 1 second. But this time we will just turn on only the red. That's it. So, but this will happen only if you put the switch 1 on the on position and the switch 2 in the off position. So let's try this. If it will result to an error. Yes. So number 40, there's an error in the else. So for the meantime, I'll remove that number 40. We'll take this down. The else from the original program that we made, so that this error will go on. Start the simulation. Okay, so the bracket should hit back for the if. Okay, so here, enter. I will put bracket. Close. I will just delete the else part here. See, I think there will still be error. So number 38. So let's see number 38. Let's check the brackets. So these are the brackets for the if, and this will be the main void loop. This one. The void loop. Now let's start the simulation again. Okay, let's click the switch number 1. Switch number 1 must be on. And then here, switch number 2 must be off. So look at this. The red LEDs are the only ones blinking. That again, when switch 1 is on and switch 2 is off. So this is switch 1, this is on, and this one is off. So let's say click this. Something should happen that all of them will not be on, or the red LEDs will not be blinking. So that's it. Let's try the switch 1 to be on and switch 2 to be off. It's blinking. But when this is off, switch 2 is on, I mean, then the LED will not do the blinking. See that? But what is it supposed to do? Maybe we can turn off all the LEDs when it is doing the wrong switching position or switch positions. So in the beginning, we have here clear the LEDs. So we can clear it here before we start. Clear all the LEDs. And then on the first situation, switch 1 and switch 2 are both off. So switch 1, switch 2 both off. So all will be off. Okay. But if switch 1 and switch 2 is on and off, then the red will blink. That's done. The last thing that we will do is when switch 2 is on and switch 1 is off. So similar to what we did here, the LEDs will also blink, but not the red. So what I'll do, I'll copy this part and I will exchange the number 1 here. Switch 1 will be off and switch 2 will be on, as given here. Switch 1 will be off, switch 2 will be on. Okay, and after that, we will be blinking the other colored LEDs. So these are the yellow, green, which is positioned on digital number 2, 3, and 6, 7. So we need to do the digital pin 2, and then 3, and then 6 and 7. So they will all be on, but before they all turn on, the LEDs will be off. So it will blink. Let's try it. Start the simulation. Condition number 3, toggle switch 2 is on. Okay, this is on. Still loading. So sometimes the simulator is hanging and we just need to try it again. Just save your work so that it will be okay. So this is simulation example with 2 switches and 8 LEDs. Okay, that's our example, and let's try it again. Start the simulation. Let's see if it will be okay. We're done if this works. So what I'll do is I'll click on switch number 2, make it on. It's already on actually. And switch number 1, I'll make it off. And what will happen? The other colors, yellow, green will turn on and off. That's the condition number 3. So we did it. And for condition number 1, when switch 1 and switch 2 are both off, all LEDs are also off. Let's try to turn this off. Switch 1. Oh, it's already off. And switch number 2, we will make it off. All LEDs must be off. Done. And the last one, when switch 1 is on and switch 2 is off, only the red LEDs will blink or toggle every 1 second. So switch 1 is on and switch 2 is off. Okay. Only the red LEDs are blinking. So that's it for our simple tutorial about using Tinkercad as a simulator. And as I've said, this tutorial, Arduino tutorial, is about how to create an Arduino simulation project that uses 8 LEDs that can be controlled by 2 switches to do the following. So switch 1, switch 2 are both off, all LEDs also off. So switch 1 off, switch 2 off, all LEDs are off. When switch 1 is on and switch 2 is off, only the red LEDs will blink every 1 second. So switch 1 is on, switch 2 is off, then only the red LEDs are blinking. And the third condition is that when switch 2 is on and switch 1 is off, the other colored LEDs will blink. So I'll make the switch 1 off and switch 2 on, and that's it. The yellow, green LEDs are blinking. Thank you so much for being with me throughout this tutorial. I hope you will subscribe, like, share, comment, and click the notification bell so that you will be updated with our latest videos. Thank you so much.